Okay, so the next thing that we have here is a standard deviation of a continuous frequency distribution. So one thing that you need to understand is, and probably you don't understand because I've never talked about it, and these things are not very simple to figure out, at least the first time that you read anything. Be it any topic, whenever you read it, there are these minute differences and terminology and everything that you don't get really. It's actually the case for me. I don't know about you. So there is something called the continuous. There is something called the continuous frequency distribution. There is something called the continuous frequency distribution, and there is something called basically a discrete frequency distribution, and discrete with an I. There is something called a discrete frequency distribution. Now the difference between these two is that the continuous frequency distribution is, for example, some set of observations where you have, for example, your classes over here and classes over here, and then you have the frequency of those classes. For example, you go from 5 to 10, 10 to 15, for example, 15 to 20, and so on and so forth. And you have the frequency of those classes. This is called a continuous frequency distribution. This is called a continuous frequency distribution. Now, in case you could also have your data in such a way that they're not put into classes, meaning that your data could be, basically you could simply have your x of i's over here, and then your f of i's related to those x of i's, and for example you have x1, x2, x3, and so on and so forth all the way up to x of n. Then you have f1, f2, f3, all the way up to f of n. So this kind of data that you have, for example, a 2 over here, a 3, a 5, a 10, and so on and so forth, this kind of distribution is called a discrete frequency distribution. Frequency distribution. Now, the formula that we had and we worked with for calculating standard deviation, which was basically sigma, was equal to the square root of, for example, 1 over n times sigma of, for example, f of I times x of I minus x bar, all squared as I goes from 1 to n. That is basically that we used it to calculate the standard deviation of a discrete frequency distribution, meaning that you have all of your x1, x2, your x2, x3, and x4, and so on and so forth. Basically, of your data, you have the frequency of those, and then you use it for that sort of thing. And we used it, of course, here, and we calculated a couple of things with that. Now, when it comes to the standard deviation of a continuous frequency distribution, which is basically you have all of your classes there, we need a formula, of course, for that case as well, which happens to be, of course, the same thing. Meaning that it says that the given continuous frequency distribution can be represented as a discrete frequency distribution by replacing each class by its midpoint, meaning that when you have a continuous frequency distribution, something like, for example, this over here, and they have your classes here, and you have your frequency related to those classes here, and here you have x1 goes x1 to x2, and then x2 to x3, and then x3 to x4, and so on and so forth. Of course, the x of i's, we don't have them over here. So, and what we did basically in such cases, in order to be able to calculate anything, we calculated something called the class mark. We calculated something called the class mark. The class mark, and we used that as our x of I. So we said that, for example, the class mark related to this class was x1 plus x2 divided by 2. For this was x2 plus x3 divided by 2. For this one was x3 plus x4 divided by 2, and so on and so forth. And so you can treat this as this number, the average of x1 and x2, as your x of I, and still use the same formula. So that's basically why it says the given continuous frequency distribution, which is basically all of this data here, can be represented as a discrete frequency distribution. Discrete frequency distribution meaning that you have your x of i's over here, basically the individual x of i's over here, and then you have your f of i's over here, and that would be called as we mentioned before, a discrete frequency distribution, by replacing each class by its midpoint, which is basically what we did over here. Then the standard deviation is calculated by the technique adopted in the case of discrete frequency distribution, which is what we did over here. If there is a frequency distribution of n classes, each class defined by its midpoint, x of I, with frequency f of I, the standard deviation will be obtained by this formula. So it's very simple, just that you need to understand basically what you're doing, otherwise there was no really point in all of this explanation, really. So it says that if there is a frequency distribution of n classes, if there is a frequency distribution of n classes, each class defined by its midpoint, each class defined by its midpoint x of I with frequency f of I the standard deviation will be obtained by the formula. The standard deviation will be obtained by the formula sigma is equal to the square root of 1 over n times sigma, basically times sigma f of I times x of I minus x bar all squared as I goes from 1 to n, and that is basically your standard deviation, which is basically the same thing as what we used to use before, but you need to understand the difference of the two distributions and well, of course, use the same formula, where x bar is the mean of the distribution, where you can say that, of course, where x bar is the mean of the distribution, and n is equal to sigma f of I as I goes from 1 to n. So that's basically the whole story here. Now, there is another formula for standard deviation. Let's see what that is. Okay, so now there is something called over here another formula for standard deviation. So we know that basically we define variance as sigma squared is equal to basically 1 over n sigma f of I times x of I minus x bar whole squared as I goes from 1 to n, which is the same thing as 1 over n sigma basically f of I times x of I whole squared, basically plus, if you this is a minus b whole squared, which is the same thing as a squared plus b squared minus 2 times ab. So plus b squared would be x bar squared negative 2 times basically x bar times, for example, x of I as I goes from 1 to n. And then you can rewrite that as 1 over n and sigma f of I you can take it out, or you can multiply it by each term, meaning that you can write this as basically 1 over n times, for example, sigma f of I times x of I squared as I goes from 1 to n, plus sigma f of I times x bar squared as I goes from 1 to n, minus 2 times minus basically sigma 2 times x bar times f of I times x of I as I goes from 1 to n. And then you can rewrite that as so of course for example, you could take the 2 and x bar out because they are just being multiplied by each term here. You can take that out. So I can write that as 1 over n. Over here I can write, for example, sigma f of I x of I squared, sigma f of I x of I squared as I goes from 1 to n, plus so over here, for example, I can take this out because this doesn't depend on I. So I can write this as x bar squared. This is not x raised to power negative 2, but this is x bar squared. X bar squared, make this a little bit longer to denote so x bar squared times sigma f of I as I goes from 1 to n, minus, again you can take this out, so 2 times x bar times sigma basically f of I x of I as I goes from 1 to n. and over here I have so over here you have sigma f of I minus sigma f of I x sub I. Now let's see what we can do with this. So I can write this as 1 over n. If I multiply this 1 over n by these three terms, what I will get is 1 over n. I will get 1 over n sigma basically f of I x sub I squared, f of I x sub I squared as I goes from 1 to n, plus basically sigma so sigma f of I as I once goes from 1 to n is equal to n. So n divided by n is equal to 1. So you would simply get x bar raised to the power 2. X bar raised to the power 2. And then if I multiply sigma, basically this thing over here, 1 over n sigma f of I x sub I as I goes from 1 to n, that is the same thing as basically x bar. This is x bar. So that is basically negative 2x bar whole squared. So that's, I can write it as negative 2 times, for example, x bar times, for example, n times, let me see, if I multiply 1 over n times sigma f of I x sub I as I goes from 1 to n, I will get basically this part. The whole part becomes x bar. So you have negative 2 x bar over x bar, which is equal to negative 2. Right? And then you have, no, I'm sorry. No, not that. So if I write basically, so if I multiply this 1 by n times this whole thing, I will get 1 over n times sigma f of I x sub I as I goes from 1 to n, which is equal to x bar. So that's this, so this becomes negative 2 times x bar times x bar. So understand what they have done here. So that's negative 2. So that you can write negative 2 as x times x bar squared, right? Which is what they have written here. Negative 2 times x bar squared. Okay, so that's that, right? So that is basically this step here, which you can write as now over here I have x bar squared negative 2 times x bar squared, which is negative basically x bar squared. These two add up to negative x bar squared. So then you have 1 over n. So then you have 1 over n sigma, basically sigma f of I x sub I squared, this whole thing over here, sigma f of I x sub I squared, as I goes from 1 to n, minus x bar squared, Okay, so that is basically that is basically sigma squared. That is sigma squared. That is sigma squared. Now, the next thing that we can calculate, so then you can say that sigma squared is 1 over n, sigma f of I x sub I squared as I goes from 1 to n, minus x bar squared. Okay, now x bar squared, you can write it this way. So x bar actually is equal to sigma f of I x sub I over n, right? Sigma f of I x sub I over n as I goes from 1 to n. So then I can write this as 1 over n sigma f of I x sub I squared minus this whole thing squared, which is basically sigma f of I x sub I as I goes from 1 to n over n squared, and that is equal to basically sigma okay. So then what you can do is, if I take a 1 over n squared out, I can write this as basically n times sigma f of I x sub I squared, okay, minus basically sigma f of I x sub I, as I goes from 1 to n all squared. And since this is sigma squared, all of these are sigma squared, then based on that you can say that sigma is equal to basically the square root of this whole thing, which becomes 1 over n, times the square root of n times sigma f of I x sub I squared minus sigma f of I x sub I as I goes from 1 to n, and here again I goes from 1 to n, this whole squared, and that is your formula. So then at the end of the day, the standard deviation sigma is 1 over n times the square root of n over basically the square root of n times sigma f of I x sub I squared minus sigma f of I x sub I whole squared as I goes from 1 to n in both cases. That is basically standard deviation, another formula for standard deviation. This we call standard deviation. Okay, that is that. Now let's do a couple of examples using these formulas, and then we have a couple more things to still cover in this chapter. So example number 10 says that calculate the mean, variance, and standard deviation. You want to calculate the mean, variance, and standard deviation standard deviation of the following distribution. And your distribution is basically you have all of these classes, and I will just simply write them in a table so that we don't have to do it twice. So here you have your classes, and then you have your frequencies f of I, and then you have, for example, 30 to 40, you have 40 to 50, you have 50 to 60, you have 60 to 70, you have 70 to 80, you have 80 to 90, and you have 90 to 100. And the frequency related to these are 3, 7, 12, 15, 8, 3, and 2. Right? Now, what you want to do here, let me see what sort of formula they have used, and then we will use the same formula. So we said that you want to use the mean and the variance and the standard deviation. So of course you know that variance, was basically sigma squared, which was equal to 1 over n times sigma f of I times x of I minus x bar whole squared as I goes from 1 to n. And of course this is squared, right? So this is your variance. So in order to calculate the variance, we need to calculate x bar as well, or the mean basically. Now in order to calculate x bar, you can calculate, for example, using this formula, for example 1 over, or let me do it my own way, which is basically sigma, for example, this is easier to understand, sigma f of I x of I over sigma f of I. Of course, you can call this whole thing n. In the book, it's been written this way. It's been written as basically, it's been written as 1 over, it's been written as 1 over n, meaning that they have taken sigma f of I as n, times sigma f of I x of I, as I goes from, for example, 1 to n, and here I goes from 1 to n, right? So you can do it this way, knowing that of course n is equal to sigma f of I. Any way that you want to do it is okay. So first we need to calculate sigma f of I x of I. Now in order to do that, you need your x of I, and the x of I is just simply not there. You have your classes and your frequencies. So what you want to do here is calculate your x of i's, which is the class mark, which you can use as the, I don't like this color, it's a dead color. Okay, so this is your class mark that you can use as your x of I, which is the average of the lower limit and the upper limit of your classes. For example, that's 70, so that's 35. That's 90, that's 45. That's 110, which is 55. That's, for example, 130, which is 50, and what is 50, 65, for example, and for the same way 75, 85, and 95. So these are your class marks. Then you need basically f of I times x of I, and then so f of I times x of I is equal to, for example, these are large numbers. These are large numbers, so I would take this as the assumed mean of the data, for example, this number over here, and then right over here and then write over here basically d of I, which I can define as x of I minus a. So for example, 35 minus 65 is equal to 35 minus 65 is 65 minus 35, 0 and 3, so that's a 30. 45 minus 65 is equal to negative 20, negative 10, 0, 10, 20 and 30. And then what you need to do is, of course, the formula that now I'm going to use for finding the mean of this data would be x bar is equal to a plus basically sigma f of I d of I over sigma f of I as I goes from 1 to n. So f of I times d of I would be now, for example, that's now easy to calculate. There's no problem with that now. So if I calculate f of I times d of I, what I will get is, for example, negative 90, negative 140, negative 120, 0, 80, 60 and 60. And then what you have is sigma f of I d of I. Sigma f of I d of I is equal to all of these numbers added together. So you have 140, this is 200. And then here you have 260, 350. So 350 and negative 350. So subtract, you will get 0, 5 and negative 150. Negative 150. Now your sigma f of I is equal to 10 plus 12 is equal to 22, 32, 37, 37, 40 and 50. So you have basically your x bar is going to be equal to a, which is 65, plus sigma f of I d of I, which is equal to negative 150 over 50, which is basically these two 5. That's a negative 3. That's a negative 3. So 65 minus is equal to 62. So your x bar is equal to 62. Now that I know what my x bar is, I can go and calculate my variance. I can go and calculate my variance as x minus x bar I have to calculate. So if I go for x minus x bar and square it, what I will get is, this is actually x of I minus x bar. Okay, so now x bar is equal to 62. So now I need to calculate x of I minus x bar whole squared, which is going to be equal to, I'm mixing every color with every other color, which is not always the best idea. So x of I minus x bar whole squared is equal to, so x of I are these values over here, and x bar is this value. So for example, 35 minus 62 is equal to 62 minus 35 with a negative sign. So you have basically 7 and 2, negative 27. Then you have basically 45 minus 62. So 62 minus 45 with a negative sign. So you have 7 and 1, negative 17. Then you have, for example, 55 minus 62, which is negative 7. Then you have 65 minus 62, which is equal to 3. 65 minus 62, which is equal to 3. Then you have 75 minus 62, which is equal to 75 minus 62, which is equal to basically 13. I don't want to make mistakes, so I do the calculation. Sometimes in your head something goes wrong, really, and you cannot see it. It happens sometimes really fast, so then you have 85 minus 62. 85 minus 62, you have basically 3 and 23. And then you have 95 minus 62, which is equal to 33. 33. Then what you have here is we have to raise all of these numbers to the second power, of course. So 27 squared is equal to 27 squared is equal to 49, 4, 14, 18, 0, and 14, 1, 5. So you have 9, 12, and 729. This is supposed to be 729. The second number is 17 squared. So 27 squared is equal to 729. Sometimes remembering these is really helpful. 17 squared is equal to 17 times 17, 49, 11, 17, so you have 2, 8, and 9, 289. 17 squared is equal to 289. So that's 289. Then you have negative 7 squared is equal to 49. This is a 9. This is a 13 squared is equal to 269. I suppose 39, 0, 1369. 169. 23 squared is 23 times 23, 9, 6, 0, 46, 9, 12, 1, 529. 529. And 33 squared is equal to 99, 0, 99, 9, 18, 1089. 1089. And then you have, let me rewrite these numbers this way here. So the numbers are 729, 289, 49, 969, 529, and 1089. And then we need to multiply f of I by these numbers. So I need to calculate f of I times x of I minus x bar whole squared, which would be basically 3 times, for example, 729. 729 times 3, which is equal to 27, 6, 8, and 21, 2187. 2187. Then you have 7 times 289. 289 times 7. 63. 56 plus 6 is equal to 62. 6, 14, 20. 2023. 2023. Then you have 12 times 49. 49 times 12, 18, 1, 8, 9, 0, 49, 8, 18, 588. 588. So let me see what is 12 times 49. 12 times 49 is 588. Then you have 15 times 9. 15 times 9 is equal to 90 here, and 45, so that's 135. 135. I have 8 times 169. 8 times 169 times 8, so there's you have 800, 480, and then you have 72, so you have 2, 15, 1, and 13, 52. 1352. 3 times 529. 529 times 3. That's a 1500. That's 3 times 20 is equal to 60. And that's a 27. So you have 7 and 8. 1587. 1587. And then you have 2 times 1089, which is 2160 and 18, which is equal to 8712, 2178. 2178. And then you want to calculate sigma f of I times x of I minus x bar whole squared. So sigma f of I times x of I minus x bar whole squared, as well as I goes from 1 to n. As I goes from 1 to n, of course, or to, basically in this case you have you have here how many x of i's you have. For example, 7 f of i's as I goes from 1 to 7, for example. So this is the sum of all of these numbers. So that's 2187, 2023, 588, 135, 1352, 1587, 2178. So you have 10 plus 8 is equal to 18. 18, 20, 25. 25 plus 15 is equal to 25 plus 15 is equal to 40. I have a 4 here. Then you have 12 plus 2 is equal to 14. 14 plus 8 is equal to 22. 22 plus 8 is equal to 30. 30 plus 15 is equal to 45. 4 here. You have a 5 plus 5 is equal to 10. 11. 11 plus 9 is equal to 11 plus 9 is equal to 20. 2 here. That's a 6, 7, 8, and 10. That's 10,050. It is 10,050. So there you have your numbers, and then you need to calculate that by, you need to divide that by n, which is sigma f of I. This is n. So you can write basically sigma squared is equal to 1 over n over basically times sigma, basically I goes from 1 to n of f of I times x of I minus x bar whole squared. So this is equal to 10,050 over 50. These two zeros you can cancel out, and 1005 divided by 5, you can take it as 2 times 5 is equal to 10. 0, 0, and 1, 201. 201. So that's your sigma squared. That is your variance. That is your variance. And your x bar is equal to 62. X bar is equal to 62. So we wanted to find the mean, the variance, and standard deviation. So of course you know that standard deviation or sigma sigma is equal to the square root of 201, meaning the square root of your variance. That is called standard deviation and not variation. I think I said variation. Standard deviation. Now the square root of 201, you can calculate it this way. You can write 201 and group your numbers in this manner, and then you can basically, the only numbers that you can multiply together whose result would be less than or equal to 2 is 1 and 1. So 1 times 1 is equal to 1, and then you can subtract, you'll get a 1, bring down the next group, and then you want to add 1 to 1. Basically you want to add 1 to itself, which becomes a 2, and then put a digit over here, and then some digits you need to put over here the same digit. So for example, if you go for 25 times 5, 25 times 5 is equal to 100, right? So 5 times 5 is equal to 25, 125, I'm sorry. So if I go for 24 times 4, I get 16 and 96. So 24 times 4 is equal to 96, and I get a 5 remainder. 5 remainder. So now if I have a decimal point here and 2 more zeros and bring them down, I get a 500. And if I add basically to 24, if I add a 4, I get a 28. So I write my 28 over here and another basically digit here, decimal point here, and another digit here. Now 28 times, for example, 282 times 2 is equal to 4 and 16, 1 and 564. So 281 times 1 is equal to 281. We go for 281 times 1, we go to 281. And then I have the remainder 4, 9 and 10, so you get 9, 1 and 2, 219. Another 2 zeros I can try, bring this down, 2 zeros, 281, add another 1 to it, I'll get 282. I'll put my 282 here, and another digit here. So now what I want to do is, for example, let's say 282 times, this becomes, if I put any digit over here, this becomes 2000, and this is 21,000, so it's around 10 times. So if I go for, I don't know, let's go in the middle, so for example 5 times 5, so that's something like 5 times 3,000 is equal to 15,000 or so. It's around 15,000. So 2826, for example, times 6, that's something about 1,200, or basically 6 times 2,000 is equal to 12,000, and 6 times 800 is equal to 40. 6 times is equal to 48. 48 and 0, 0, you'll get 16,800. If I go for example, a 7, if I go for a 7, I'll get 2827 times 7. I get something like, for example, 7 times 2,000 is 14. 2,000 is 14,000, and 7 times 800 is 5,600. 5,600, and I get 00602. 20,600, for example. This is the closest that I can get. So I put a 7 over here, and I'll write 2,600. And now if I subtract, I get a 0, 0, 3, and 1, and 0. And I don't want to basically go any further than that. I write this at approximately 14.17. And well, if I do this calculation using a calculator, let's see what we get. If I write the square root of 201, 14.177, exactly right. Now let's go back to the book. Let's see what sort of answer we got over here. So the mean is 62, which is correct. The mean is 62, which is correct. The variance is basically 201, which is correct. And the standard deviation is 14.18 because in the calculation we got 14.177 and so on and so forth. So you can round it up to 14.18. So 14.18 is the right answer there. Write it properly. 14.18. And that is the answer there. Now the next question that we have is again another question here. It seems we have a couple of some theory here going on before we can do any exercises really. But I think we should end this video here, I suppose.